Bienvenidos, Hushamadid, and welcome CMIT-455 Section 6380 learners for the spring 2021 semester. This is the CCNP ENCOR version 8 curriculum, and in this supplemental video tutorial, we're going to be expanding on a topic that we've been following in Chapter 16. Specifically, we started with Packet Tracer Activity 16.2.2, where we looked at creating a point-to-point IPsec VPN between two sites. We then, in the first supplemental video tutorial, took a look at what would be required to do GRE, or a generic routing encapsulation tunnel, over IPsec. And the reason that we looked at doing that is because we wanted to run an interior gateway routing protocol like OSPF or EIGRP, and we configured OSPF in that video. And GRE is what allowed the multicast traffic to flow. Remember, IPsec works with IPv4, but IPv4 unicast when you're only using IPsec. So we had to come up with a solution to allow for a routing protocol to work over that IPsec tunnel. And so we chose GRE. So GRE over IPvSec, but again, we had to create the crypto map and apply the crypto map to the physical interface. And so now, again, kind of chronologically following the advancements with IPsec tunnels, Cisco started out with crypto maps with IPsec, then we came to GRE over IPsec, and now we're going to be looking at the Static Virtual Tunnel Interface, or SVTI. And as you might imagine, this again is a point-to-point solution. And we're going to be looking at it through the lens of EIGRP with default settings. And so I'm going to show you just how simple it would be to quickly stand up a tunnel using EIGRP version 1 and default settings for EIGRP phase 1. In other words, ISACAMP or EIGRP phase 1. And remember, EIGRP is the Internet Key Exchange Protocol, and that's all about our key management. And ISACAMP is the framework that's used by EIGRP. In other words, ISACAMP defines the requirements to build a security association between two devices, and EIGRP uses ISACAMP as part of the key negotiation. But there's a default phase 1 ISACAMP/EIGRP profile that we can deploy here that can save us a lot of time if we don't want to go in and choose the encryption, choose the hash, set up other settings that we would do under phase 1. What we can do here is just simply apply tunnel protection and pick the default profile. And it's a little tricky because when you say tunnel protection IPsec profile question mark, you won't see default. But if you type default out, and we're going to do that in this video, you'll see exactly how that's going to work. And so we'll talk about some of the differences, right, between the static virtual tunnel interface and crypto maps. No more access lists. We're not applying a crypto map to a physical interface, and we're actually not doing crypto maps at all. So that's going to save us a lot of time there. Scalability is much nicer, and we're not using GRE anymore. And so you'll see that there's two commands we're going to add to our tunnel interface. The first is going to be tunnel mode IPsec, and then the protocol we're using, IPv4, IPv6, and then tunnel protection IPsec, and then we refer to the profile. Now, the profile is something that we would create that you might think, well, it's a little like a crypto map, because we're having to do that instead of the crypto map. And then we reference that profile. But as you'll see, it's a little easier to set up. And all this is being done on virtual interfaces, right? They're all being done, and all this work is going to be done on virtual interfaces. So let's go ahead and dive in and take a look at the topology we're going to be working with. And it's the same one you're very familiar with already. So let's pull PCA up. And again, you can see that the pings for PCA trying to ping over to PCB have stopped because the configurations on router 1 California and router 2 New York have been wiped clean. Let's take a look at PCB and we'll see the same thing here. The pings have stopped. We'll start them up again because this is going to be our indicator as to whether or not things are working. So again, we're getting rid of the GRE tunnel, we're getting rid of the crypto map, and then we're getting rid of the GRE overhead if that was a concern, although in modern networks might not be that big of a concern, but we're getting rid of GRE. And so the secret sauce here is that tunnel mode IPsec IPv4. And then behind the scenes, the SVTI is going to support IP unicast and IP multicast. In fact, SVTIs only support unicast and multicast with IP. That is it, right? And there's a thing called the traffic selector that's also kind of in the background, right? That's the, sort of hidden from view that we used to do with ACLs with crypto maps. However, here it's just IP any for the traffic. And then we, doing routing, make sure that the traffic gets pushed into the tunnel. And then behind the scenes, everything's taken care of for us. So let's jump on router 1. And again, we're using the phase 1 defaults, and I'm going to show you how to see what those defaults are, and we'll discuss those in a second, for the ISACAMP phase 1. What's protecting the keying material? Remember, phase 1 is the control plane. It's about proving identities between the two devices and protecting that keying material. And this is where the CIA comes into play, right? We're going to have confidentiality with encryption. We're going to have integrity with a hashing algorithm. And we're going to have authentication using IKE for the secure key exchange. And that's where the Diffie-Hellman component comes in. And so we'll see what this is going to look like. So let's get into global config. And really, we don't have to say crypto ISACAMP and create a policy because we're going to use the default policy. But if the default is pre-shared key, right? If I want to use a pre-shared key, then we still have to put the key in, right? So crypto ISACAMP key, and we'll say ABC123, and then we're going to put in the address. Again, you could go quad zeros, and that would allow a connection from anybody to try to negotiate the phase 1 secure keying material with you. And so what's preferable to that is to say 209.165.20.222. So put in the exact IP address. Again, this is point to point. So we're only setting this up with a single device right here. And so that is going to be a good way to approach things. And so for phase 1 configuration, that's it. It isn't that simple, right? Again, we're using the defaults, and we'll talk about what the defaults, and there's, I believe, 8 different profiles that'll come up, and I have a document we'll take a quick look at that'll show you what those defaults are, and we'll see them here from the CLI. But that's it for phase 1. Phase 1 is complete. And so then now I'm going to go ahead and configure my tunnel. So we'll say interface tunnel 0. And what do we need on the tunnel? Well, we need the IP 10.0.0.1. And we'll use the same values we used in previous videos. We need the tunnel source. We know that's gig01. We need the tunnel destination. We know that that's the outside, right? The publicly routable IP address on the interface of router 2 New York that's connected to the ISP. And we know that that's 20.222. So we have the address for the destination. We have our source. We have our IP on the tunnel. Now, here are the 2 commands that are really the only 2 different commands that we would apply here. And the first is going to be tunnel mode IPsec. Right now, remember, we talked in 16.2.2 about tunnel mode tunnel mode GRE IP, right? Where we said, oh yeah, this is going to be a GRE encapsulated tunnel. But here, that's not what we're going to be doing. We're going to be saying it's an IPsec tunnel. And are we doing IPv4 or IPv6? Well, here we're doing IPv4. Again, if you were doing IPv6, you would select IPv6. So this is the first different command on the tunnel that's going to be required. Now, the next command is going to be tunnel protection. And this is where we're going to say IPsec and we have a profile. Now, typically, the profile would refer to your phase 2, ISACAMP IPsec phase 2 transform set. But here, we're going to say that the transform set, and what we're going to be using is simply, and if I do a question mark, which I'd commented on earlier, you can see it says enter a word. It doesn't say that you can type in default, but we are going to go ahead and type in default, right? And so you can see ISACAMP has come on. So how do we see what those values are? So what if I say show crypto IP, or not IPsec, sorry, ISACAMP, and if I do a question mark, you can see there's a keyword here for default policy. That should be it there. All right, now all these things, I'm going to let them all scroll by here on the screen. And you're going to see, I believe it's about 8 different default policies. Now, the question is, well, which one is going to be used? Well, take a look here. The first one, and the way that it works is 65507, and then 08, and then 09. This is the highest priority one right here, 65507. So if we can match up with the other side with these settings, then we're good to go. And you can see that, using the default is probably not going to be a good idea because there's Diffie-Hellman group 5, right? So that might be a problem. And then you've got the hashing algorithm. We're using Secure Hash Standard, AES 128-bit keys. And you can see here, we've got the lifetime, 86,400 seconds. And so this is the first profile that might be used in order to set yourself up with the encryption. And so I'm just taking a look here real quick. So let's take a look real briefly here at the default IKE phase 1 policies. And again, those are these policies that we just saw right here. And so the first one you looked at was an RSA, right? So it was like a certificate type setup with RSA, but we're using pre-shared key. So what would happen is this side would try to figure out if the other side is using pre-shared key with AES encryption with SHA in Diffie-Hellman group 5. And you can see that the groups drop off here from 5 to 2, which is even worse, right? But again, their defaults, maybe at some point these will update and change, but for right now, those are the defaults. And so if I do the defaults on one side, I can also do those default settings on the other side, and I could set those manually on the other side as long as they would match one of these pre-shared key default configurations with triple DES, MD5, and Diffie-Hellman 2, or pre-shared key AES, SHA, and Diffie-Hellman group 5. And again, these are these IKE policies, right, for phase 1. If I scoot back up here, for phase 1. Now, it mentions this next generation encryption. And this is another great resource to take a look at here. And all you have to do is Google Cisco Next Generation Encryption, because this is what you keep handy. And these are quantum computing resistant algorithms listed here in this column, the QCR column, right? And NGE stands for Next Generation Encryption. And so when you're making your decisions as to what it is you're going to use, this is where you want to be. And so you can see right here that AES CBC mode for the encryption is acceptable. And here's the alternative, is the GCM mode, right? And then it gets into, there'll be the elliptical curve stuff that we had talked about earlier. And so you can see here that these are okay in terms of being quantum computing resistant. So you would want to use these values when you're manually defining your phase 1 and phase 2 configuration. And the same thing is true here down in the SHA, right? You can see there's only 2 hashing algorithms, the SHA 384 and 512, that are considered quantum computing resistant. And then you've got the HMAC SHA 256. And remember, ESP, right, when we configure that encapsulation security payload, or protocol, payload or protocol. Sometimes I'll say both. But when we configure ESP, that's why we're choosing that for our integrity. And you can see here up again, talk about the CIA. Encryption is our C, right? We've got authenticated encryption, and authentication is our A, and then integrity, that hashing algorithm, making sure things aren't changed in transit, that's our I. So there's our CIA. And so this really kind of narrows it down. You should be using HMAC SHA-256 for integrity, or SHA-512, or 384, and then the AES encryption algorithms. Everything else, and you can even see right here the status, they tell you, avoid DES. Legacy is triple DES. Avoid RC4, right? So a lot of these things, and take a look at these RSA, Diffie-Hellman key links for the key exchange. So lots of things to be wary of. So make sure that you come in and refer to this document to make sure, and then it explains here about the quantum computing resistance. So keep that in mind when you're setting those things up. And so let's drop back over here. Sorry about that. I'm going to come back over here to the Cisco Modeling Labs. So we've set this side up. We've set the tunnel up. And so right now, the tunnel interface is ready on this side, but not on the router 2 side. So on the router 2 side, and we'll move through it a little quicker pace since we've covered a lot of ground here already. So let's get into global config. Sorry, we'll get into global config, and we'll say crypto ISACAMP key ABC 123, and then the address is going to be that publicly routable IP that we can get to, 209.165.10.111. And so there's our pre-shared key settings. We'll get into interface, tunnel 0, IP address 10.0.0.2, make it a /24. And then we'll say tunnel source, tunnel source is going to be gig02. Tunnel destination is going to be the 209.165.10.111. And then we have these 2 new commands, right, that are kind of the secret sauce behind the curtain that's doing all this tunnel mode. IPsec, IPv4, because we're using IPv4. And tunnel protection, IPsec, tunnel protection, misspelled tunnel there. Tunnel protection, IPsec profile, and again, we're going to put in default. Now, you'll notice that it even tells us right here, crypto ISACAMP policy using ISACAMP default policies. And then the tunnel looks like it changed its state to up. So what should we see right now? Remember, I made a comment in the previous video, the SVTI, and I think I might have made it in this video, is always up. It's always on. So what if I say show IP interface brief? What are we going to see? Well, there's our tunnel interface, and you can see that that tunnel interface is up. Now, I haven't run any ping commands yet or done anything like that. In fact, look at PCB. Still not working, right? Still can't ping PCA, and PCA still can't ping PCB. But we already know why that is. The tunnel is there. It's all set up. We've got IPsec protecting the traffic that's going to be inside this tunnel. We're not using GRE. Remember SVTIs, unicast and multicast only. We know we don't have the routing information. If I say show IP route, we don't have the routing information for the 192.168.20 on this side, and on the other side, we don't have the routing information for the 192.168.10. And we're going to use EIGRP in this video to make that happen. However, let's take a look at a few other things first. So if I say show crypto ISACAMP SA, you can see that we are in quiet mode idle. Again, talking about those messages with IKEv1. Remember, we're IKEv1, where we're dealing with main mode that has 6 messages, aggressive mode, or I say packets, and aggressive mode has 3 packets, and then we've got the quiet mode, right? And so with quiet mode, we see that our status is idle, meaning the keying material has been exchanged. Phase 1, right, that handshake with the moving company and the exchange of the check to pay for things, that's all been done. The foundation is laid. Now we can run traffic through the tunnel, but that's the phase 1. Let's see what phase 2 looks like. So show crypto IPsec SA. And what do we have here? Well, you can see that we actually did have some packets that were encapsulated, but nothing's been decapsulated yet, or de-encapsulated. And you can see we've got the peer information, you can see the tunnel information, and let's take a look at the crypto endpoint information that we see here. Let me come down a little bit further. All right. And so we can see the transform set defaults that we used, which was just ESP AES and then ESP SHA HMAC. And so when we had said default, all of this was kind of done for us. And that's the tunnel protection IPsec profile, right? Which is protecting the traffic. And these are the default values that were selected. In fact, if I was to come back up and say, where are we at here? What do I want? I want to say detail, I believe. And detail is going to actually look a whole lot like what we just saw. And I was hoping to see something else. No. So again, you got your security parameter index, a value that we talked about in the very first video. But again, there's that transform set. And so those are the default values we're using. Now, would these be the values you would want to use? It depends on your use case and how, important the data is that you're sending. So the tunnel is actually already up. So you saw no GRE configuration, no ACLs, no crypto maps applied to physical interfaces. It's all being done on the virtual tunnel interface, right? VTI, that static virtual tunnel interface is where this is all happening. So if I ping 10.0.0.2, you can see I can ping across the tunnel and we've got reachability there. So if I've got reachability across the tunnel, right, and the SVTI supports unicast and multicast IP traffic only, then I should be good to go here. So let's get into global config. I'm simply going to say router EIGRP1. We'll do a classic mode configuration here with EIGRP. I could say EIGRP router ID. We could set the router ID. And then I could say network. And let's say 10.0.0. What are we going to do? 1. And then we'll do 0.0.0.0. And then we want to advertise the 192.168.10.0. And here's the thing. And so I'm going to stop right here because you'll notice it says wildcard bits. On newer Cisco iOS, and I'm going to test to see if it works here, you can actually put in the subnet mask and dotted decimal notation, and it will convert it to the wildcard mask for you. You'll notice we didn't get an error message here. So let's say do show run section router EIGRP, and let's see if iOS converted the dotted decimal subnet into the wildcard bits. And again, it's classful, so we don't see anything here, right? So it did do what it was supposed to do. So we got away with using the subnet mask instead of the wildcard mask. All right, so that's it for router 1. Now all we need to do is come over here to router 2, and we're going to configure EIGRP. Router EIGRP1. We're going to set the router ID. Sorry, we'll set the EIGRP router ID, EIGRP router ID to 0.0.0.2. And then we're going to say network 10. Actually, we'll do the 192.168.20.0. In fact, I could hit enter right there because we're subnetting into the classful boundary. So we're okay. And then we're going to say network. And now this is the one that's going to count here in terms of the EIGRP adjacency coming up. So let's take one last look here. PCB, still not pinging. PCA, still not pinging because we don't have the EIGRP adjacency that is originating the LAN networks on each of their respective sides. But when I hit enter like that, we're going to see the adjacency that come up over the tunnel, and boom, traffic is flowing. So let's recap what we did here. And hopefully, based off just the length of this video, you should see how quick and easy it is if you're using the defaults. And again, if we weren't using the defaults, we'd create our ISACANT policy and then our transform set. And then we need to do a profile, create an IPsec profile that we reference in the tunnel interface. But with the default settings, take a look at how easy this was. Show run int tunnel 0. There's my tunnel interface configuration, and then show run include, did I say crypto? So crypto, which was our key. This should be our shared key. And that's it. That was all that was required. The tunnel interface with 2 new tunnel commands, and then the crypto ISACAMP shared key. And this is leveraging the defaults. And we also saw how to look at the defaults. We saw a document that you can Google that explains about the ISACAMP phase 1 defaults. And we saw what we ended up with the transform set, the ESP AES, and then the SHA settings. And then we looked at next gen encryption. And so that is going to do it for this supplemental video tutorial. Now, obviously, the next video is where we're going to create a phase 1 ISACAMP policy and a transform set that you would actually want to use in a production environment where you had information that you really wanted to protect. All right, well, there's a soft landing, easy introduction into the static virtual tunnel interface. Remember, this is sort of the way that these point-to-point tunnels are being done today. People really aren't using crypto maps a lot because they just don't scale. They're very cumbersome. You got the crypto map you've got to set up. You got the ACL you got to work with. If you're using IPsec and you wanted to run a routing protocol, well, then chances are you're going to have GRE on top of that IPsec. So again, we got rid of all of those things. And you saw just how quick and easy it is to get this set up. All right, guys, thanks for watching, and I hope to see you in the next video.